Okay, right. So first, let me introduce myself. My name is Venkata Prasad. I have more than 17 years of experience, very nearly 18
Hi,
years of experience.
sorry to interrupt. I think that I'm audible.
Yes, audible. Okay,
Sorry for the. Yeah, please go ahead. Sorry.
am I audible?
Yeah, Venkat, you are audible.
Okay, right. Okay, fine. Okay, so today is the first demo session. In this demo, first we'll discuss about the fundamentals, okay, and relational database management system, the core concept of SQL Server. Okay, now let me start. One second. Right, SQL Server. SQL Server. What is SQL Server? What is SQL Server? SQL Server. SQL Server is a relational relational database management system. SQL Server is a relational database management system. That means RDBMS. Developed by Microsoft. Developed by Microsoft. Okay. It is used to store, organize, and manage data. Manage data. And also it allows users to retrieve or modify the data efficiently using SQL, that means query language structured query language. Okay, so SQL Server is a relational database management system which is developed by Microsoft, and it is used to store and organize and also to manage data, and it allows users to retrieve or modify the data efficiently using structured query language. Right, now, in simple terms, SQL Server is a software that helps us to store large amounts of data safely and retrieve it whenever it is needed. Right, now let us see the versions of SQL Server. Versions of SQL Server. Okay, these are the versions of SQL Server. The first version here in 1991, the first version, SQL Server 1.1, was released, and later in 1993, 4.2 was released, 1995, 6.0, 96, 6.5, and 98, 7.0. And in 2000, SQL Server 2000 was released. Okay, till 1918, they have given the version number 1.1 to 4.2, 6.0, like that. Okay, but from 2000 onwards, Microsoft started uh, giving the version number here. In which year it is released, the year has been taken it as a version number. So SQL Server 2000 was released in 2000. 2005 was released in 2005, like that till 2025. You see, it was released in 2025. Okay, now we are going to learn SQL Server 2025 version. Okay, and it is fully AI enabled. Okay, so Microsoft has made it AI enabled. It has integrated AI features into database engine. So users can build AI applications easily by using TSQL or combine a vector and keyword search. Many things are there. It has ability to connect to the external AI models and services. Okay. Now, first, let us try to understand the basic fundamentals of database management system. Here clearly I mentioned this is a relational database management system. Okay. What it is exactly? Just try to understand or try to recollect the fundamentals once. Okay. Now, just see the fundamentals. We have what is this? First, see relational database management system. It is relational database management system. Okay. First, just try to recollect what is data, what is database, and database management system. After that, we will understand a relational database management system. Okay. These just fundamentals of database systems. Fundamentals of database systems. The first one is data. Next one is database. Right. Next, DBMS, database management system, and a relational database management system. Relational database management system. Okay. Now see one by one. Just 10 to 15 minutes. Let me explain the basic concepts. Okay. Now, what is data? Data is a raw fact or figure. Raw fact or figure that has no meaning by itself. Data is a raw fact or figure that has no meaning by itself. Okay. And what is database? Database is database is an organized collection of data. And DBMS, database management system. Okay. It is a software that helps to create, store, manage, and retrieve data from a database. Okay. And relational database management system. What it is? It is also a software, same DBMS. Okay. A software system that stores data in tables, that means rows and columns, and manages relationships between the tables using keys and SQL. Okay. It's a software system that stores data in tables, rows and columns, and manages relationships between those tables, okay, using keys and SQL. Okay. Now just try to understand one by one separately, then I will combine them later. Okay. Now just see what is data. Data is a raw fact or figure that has no meaning by itself. That means simply you can, if you have numbers, that is data. Okay, it can be numbers, it can be characters, symbols, even images also, that is data. Okay, that are collected but not yet processed. Not yet processed. That means it is unprocessed and unorganized. Unprocessed and unorganized. Numbers you take, names you take, symbols, any data in, or any data in tabular format also. For example, take another example, your marks list, marks memorandum you get after completion of your graduation. You see in it, it contains only your marks secured in each subject, but by itself, it does not clearly say anything. So this is unprocessed. Whereas if you see information, there is a little bit difference between data and information. Information, what does it mean? It means meaningful data. That means processed data. Processed data. Okay, student A passed the examination with 80%. With 80%. That is information. Student A secured rank A plus. That is information. Okay, so slight difference between data. The data in the sense unprocessed. Whereas information means processed data. Okay, that is information. So data is processed and information means meaningful data. Okay, it helps in decision making, right? So there are many types of data. There are many types of data, and the main types of data are the first one is structured data. Structured data. Structured data. Second one, unstructured data. Third one, structured data, unstructured data, and third one, semi-structured data. Semi-structured data. Structured data means data stored in predefined format. Predefined format. That means organized in columns and rows and columns. Rows and columns. Organized in rows and columns. That means well organized in tables, right? So the next one is unstructured data. Unstructured data. That means data that is that has no predefined format. That means data with no predefined format. Okay, that means it has no fixed format. It has no fixed format. That is unstructured data. Unstructured data. Okay, if you take videos, emails, PDF files, images, okay, that is unstructured data. It has no predefined format. Okay, whereas structured means data arranged in rows and columns. Okay, semi-structured. Semi-structured means data that is not fully structured. That is not fully structured like tables. Okay, but it has some organizational tags or markers. That means XML you take, XML, JSON, okay, API data. That means even you can take emails, metadata also. Okay, it is not fully structured. Okay, so structured data means data stored in predefined format. That means rows and columns. Unstructured means no predefined format. Examples of what I said: videos, images, okay, social media posts, PDF files, some documents. Okay, so semi-structured means it is not fully structured. It is not fully structured. XML, JSON, okay, and also log files. These are semi-structured. Comes under semi-structured. Okay, now what is database? Database is an organized collection of data. Organized collection of data. That means it is a digital storage system where data is organized in a structured way, so it can be easily accessed, managed, updated, and retrieved whenever it is needed. That is database, which contains data. Database which contains data. And database management system, simply you try to understand the name itself saying it is for managing data. Managing data. That means it is a software that helps to create, store, manage, and retrieve data from databases. That means it is used to manage the databases. Databases. It's a software through which only we can access databases. Okay, it is a digital storage system. Okay, there are these databases. We have many types. Relational databases, now we are going to discuss about it. NoSQL databases, hierarchical databases, network databases, object-oriented databases, multi-model databases, cloud, and many things are there. Okay, databases are many things. Okay, now we are concerned with mainly relational database that we will discuss. Okay, now database management system. I said it's a software through which we can manage the databases, I said. Okay, now now try to understand. Now the thing is, let me show you the PPT here. See here what I said: data, structured data, unstructured data, semi-structured data. Structured in the sense which is well organized. See, this is well organized. Okay, that means, see, tabular format. Data is in tabular format. Unstructured data. Data has no fixed format. See, it has no fixed format. That means documents, images, audio files, messages, kind of things comes under unstructured data. Semi-structured in the sense XML, JSON data, metadata, etc. Okay, these are comes under semi-structured data. Okay, now let us try to understand how things will change based on the type of data and the database and the database management software, how they are linked together. Let us try to understand that. Okay, now now thing is here, I said what I said here. The first one is structured data. First one is structured data. 1 second. Does this message? Okay, right. The first one is structured data, I said, right? Structured data. That means data is stored in rows and columns format. Rows and columns format. Okay. Since this database is maintaining the structured data, it is a relational database. Relational database. Okay, I will tell you why it is a relational database. I will tell you. Okay, because here EF Cod, he was a scientist in IBM. He introduced some rules, cod rules. We call them as cod rules. Okay, that we will see. According to the 12 rules of cod, the database has to maintain these relations. Okay, that concept I will explain a little bit later. But since it is maintaining the structured data, it is relational database. It is relational database. Okay, so a software which is used to manage this relational database is called a relational database management system. A software that is used to manage the relational database is called a relational database management system. Okay, and in order to communicate with these databases, what databases? Relational database. What it contains? Structured data. Structured data. So in order to communicate with these relational databases which contains structured data, which accommodates structured data, a language was introduced, and that language is called as structured query language. Structured query language, in order to communicate with this database. Okay, creating, retrieving, everything we can do it with the structured query language, SQL, structured query language. And see the examples of RDBMS softwares: SQL Server, Oracle, MySQL, DB2, PostgreSQL, These are the examples of relational database management system. Relational database management system. Okay. Now see the other one. What I said, data, the main types of data we discussed. Okay. The first one is done, structured data. The remaining two things you see, unstructured data and semi-structured data. Okay, to maintain this data, we have another database, and the database is called as NoSQL database. And a software is there to maintain these kind of databases. NoSQL database is called NoSQL database management system. This is the NoSQL database management system. Okay, and like relational database management system, there we have SQL structured query language to communicate with the database, but we don't have a universal language here. Here, the companies MongoDB and Cassandra, they designed their own languages, and we call them here Mongo query language, which is designed by MongoDB, and a Cassandra query language, which is designed by Cassandra. Okay, they designed their own languages to communicate with the NoSQL database, which contains unstructured and semi-structured data. Okay, that is the thing, right? Now, now let's go back to here. Right. So this is a relational database management system. I said what it is. It's a software system that stores data in tables. That means rows and columns, and manages relationship between the keys and tables using keys and SQL. Okay. Now try to understand, because it is the core concept of SQL Server. If you learn SQL Server, that means you are learning a relational database management system. It's a software, I said. Okay. If you learn relational database concept, that means you can learn SQL Server, Oracle, DB2, many things are there. Okay. Those are also relational database management systems. I said, I gave an example for that. Okay. Now let us go a little bit deeper into this concept, because it is the main part here. Okay, just try to understand each and every point here. Relational database management system. Okay, that means RDBMS. Okay, now see the first point. It is a type of DBMS, database management system, that stores data in the form of tables. We already discussed about that. Okay, tables, that means rows and columns. Okay, the relational part means data in different tables are connected, that means related through keys. Okay, and the concept of RDBMS was introduced by Edgar Frank Card, EF Card. We call him as EF Card. Okay, an IBM computer scientist. Okay, now he also created 12 famous rules. 12 famous rules. We call them as Card's rules. records rules to define what a true RDBMS true RDBMS should support. Okay, that means what he's saying is a database that follows all 12 rules is called a perfect RDBMS. Okay. Now, actually, it was introduced in 1980. It was introduced in 1980s. Okay. Now, let us see. Here we have 12 rules. Here we need not go to see each and every point here. Just try to understand the first two rules here. Okay, information rule and guarantee rules. These are the 12 rules. If any database which follows these 12 rules is called a perfect RDBMS. Okay, perfect RDBMS. These are the 12 rules. Okay, just try to understand the rule number 1. No need to go through all the points here, all the rules. Just try to understand the first one. Rule 1, information rule. What it is? Information rule. What it says is all data should be stored in tables. All data should be stored in tables. That means rows and columns. The first point is all data should be stored in tables. That means rows and columns. Okay, just try to see this one. The first this is the one. Okay, let us see. Let me take this table. All data should be stored in tables. Here we have employee table. Okay, employee table we have. And see, these are, we have employee ID, e-name, job. Okay, what it is saying, all data should be stored in tables. Here we have employee table and which contains employees information. Here these are the things: employee ID, e-name, job. These are called as columns or fields or attributes. Employee ID is a column or a field or or attribute. Okay, this is a field or column or attribute. Like that we can have many columns. Okay, now this information, 101 Rahul manager, 102 Ravi salesman, these you think you see, try to understand this. This is a row or a record. This is a row or a record. This is a row or a record. Okay, row or record are tuples. We can call them as rows or records or tuples. 3 rows are there, 3 records are there, 3 tuples are there. Okay, and 3 columns are there, 3 fields are there, 3 attributes are there. Okay, the first point, what it is saying, all data should be stored in tables. Okay, here we have each row or record in the sense 1 employee record. Here 3 employee records are there. If 1000 employees are there, 1000 employee records will be there. Okay, now you just see here columns in the sense what? Columns, collection of values belongs to one field. Collection of values belongs to one field. Column in the sense, this is one column, employee ID is one column, employee name is one column, job is one column. That means collection of values belongs to one field. Again, employee ID, name, job. This is column. This is a column. Okay, this is a column, right? So collection of values belongs to one field. These are values. These are values. Okay, collection of these values belongs to one field. Here job, here name, here employee ID. Okay, now columns in the sense what? Collection of values belongs to one field. One field. Okay, now what is a row? Row means what? Collection of field values. Collection of field values. See, collection of field values. Then what is a table? Table means collection of rows and columns. Collection of rows and columns. Okay, that is table. Then what is database? Database means collection of tables. Collection of tables. That means columns in the sense collection of values belongs to one field. Row in the sense collection of field values. Table in the sense collection of rows and columns. And finally database means what? Collection of tables. Okay, collection of tables. Now see the second rule. Second rule is what? Guaranteed access rule. Guaranteed access rule. Rule number 2. Rule number 2. What is that? Guaranteed access rule. Guaranteed access rule. This is second rule. Okay, what it says is every table must contain a primary key. Must contain a primary key to identify the records uniquely. This point is very important. Every table must contain a primary key to identify the records uniquely. Okay, that's what it is. Okay, now just take here. We have one more table. This is one more table. This is a table. Okay, you see here we have employee ID. This is a field or a column. Employee name, job title we have, salary we have, date of joining we have. Okay, so this is employee table. Suppose in a company 10,000 employees are there. Okay, and just assume, try to understand this point, very important. Let's assume there may be number of employees with the same name, same job, same rate of joining, or even salary also. Okay, then how do we update the information based on which condition? I want to update the record based on which condition. How can I update the record? That's why if we have a primary key column like employee ID, here employee ID we have. Okay, first just assume this we don't have. Employee ID we don't have, and we have this information only. Okay, if you have information like this, these 4 fields are there, and if I want to update a record, how can you identify a record first, and how can you update that record? Based on which field? Here date of joining same, salary is same, software engineer job title is same, and name is also same. There is a chance of having that records also, right? There is a chance of having that. Okay, instead of that, if we have a column like a primary key, see employee ID I have 101 is given to this record, this employee. It is an employee ID. One ID is given to one employee, right? 102, 103. Okay, so one employee is given one employee ID. Okay, so if I maintain employee ID in this table, so I can easily identify each record uniquely now. Then this is a unique record because it has 101 employee ID. Based on this employee ID, I can update this salary. Based on this employee ID, I can update anything here, date of joining or job title, something, right? So I can uniquely identify each record if I have unique or primary key, okay? Not only employee ID, many examples are there. Bank uses account number. Account number, it's a primary key. Government organizations, they use Aadhaar number. It's a primary key. Income tax department, they use PAN number, and election department uses what? Voter ID. Okay. These things we can use. Even serial number also we can use. No issue. Serial number also you can use to identify records uniquely. Okay, so any customer, if he wants to, a bank employee or a bank customer, he goes to the bank, and if he wants to change its address, immediately that bank officer, he will ask what's your account number, right? So based on the account number, he can update that record. That means account number is a primary key, right? Like employee ID, Aadhaar number, PAN number, voter ID, account number, many things are there. Like that, we can maintain a primary key to identify records uniquely. Okay, that is the advantage, right? This is guaranteed access. What it is saying, every table must contain a primary key. Here, employee ID is the primary key, right? Now let us see the features of RDBMS. Try to understand the features of RDBMS. These are the features. What are they? Easy to access and manipulate data. Less redundancy. That means duplication of data. Redundancy means duplication of data. Less redundancy, more security, guarantees data quality and consistency. That means data integrity. It supports data sharing, supports transactions. Okay. Now let us see one by one. What are the features of RDBMS? The first one, easy to access and manipulate data. Easy to access and manipulate data. Okay, in RDBMS, data manipulation means working with the existing data inside the tables. That means adding a row, adding a record, changing means update a record, or removing means what? Deleting a record, like that. Okay. Earlier, before RDBMS, the programmers or developers, they used to write huge lines of code to do this work. Okay, so but later, after the RDBMS evolution of these database management systems, so in 1980s, RDBMS came into the market. After that, people started using a language. I said SQL, structured query language. Simply by writing a query, they can do it easily. Okay, adding a record, that means insert a record, changing, update a record, removing, that means delete a record. Okay, they started using structured query language. They are the queries or commands. Using that, we can do it very simply. Okay, that means easy to access and manipulate data. Okay, the next point is less redundancy. Okay, actually earlier, in the old systems, redundancy was more, but in RDBMS it is less redundancy. Just see here, I have an example. Just see, this is employee table, which has employee ID, e-name, salary, department number, d-name, that means department name, location. Okay, so for all this here 100 records, just assume this here 100 employees are there. Okay, so these department details are repeated. You see, location is repeated, d-name is, department name is repeated, department number is repeated. Okay, this is redundancy. Problem with redundancy is memory wastage. If it is 100 employees, that is okay. Tomorrow, if I have 1000 employees, means 1000 times I have to maintain all these values, right? If it is 10,000, definitely memory wastage will be there now. Okay, that means unnecessarily we are wasting the memory to store these details. And another problem is what if I don't have this data? If I don't have this data, if I ask what is the department name of the department number 10, you cannot tell anything, because if data is there, you can tell it. If data is not there, you cannot tell it. Okay, because along with the employee data, department details are also maintained. So if I remove employees data, means this department data is not there. Okay, so in that case, if I ask the name of the department where department number is 10, we cannot say anything now, because if data is not there, how can we answer that? Okay, and also updation, you see, I want to update here department 10 is there. Okay, I want to update a department name of department number 10. This Hyderabad, as of now it is Hyderabad. I want to make it Chennai. I want to update it. If I have 10,000 records, that means 10,000 records, 10,000 updates I have to do. Okay, so in unnecessarily we are maintaining this data in one table, and even for updating also it is taking too much time. We have to update in each record. Okay, so there are a lot of problems for this kind of what you call maintaining table, a unique one table, having all the information in a single table. So here, yeah, what RDBM is saying is to get rid of this problem, RDBM is saying to maintain multiple tables, multiple tables. That means, wait 1 second, maintaining multiple tables. Okay, now the same data you see here, employee table, employee ID, e-name, salary, department number, department table, department number, department name, location. What it is saying is maintain the data in multiple tables. See, earlier it is one table, now it is two tables, employee table, department table. And what it is saying is maintain a relationship between these two tables, maintain a relationship between these two tables by using a primary key. Okay, that means here in department table, department number is primary key. That means we can uniquely identify records. What does it mean? We can identify records uniquely, right? And to maintain the relationship between these two tables, we will use this primary key in employee table. See, department number we have, department number we have in employee table. Now, the primary key in department table, the same primary key we use here, now it becomes foreign key. Now it becomes foreign key. Okay, that means if I want to get employees information along with the department name and location, since I have a common column here, I can write a query to get the complete employees details based on a condition department number, because department number is same in both the tables. That means we are maintaining a relationship between these two tables. That is the advantage. Okay, and that what's this RDBM saying is exactly to maintain the multiple tables and maintaining the relationship between the tables using primary key foreign key concept. Okay, that is about less redundancy. It is another feature of RDBMS. Okay, more security, more security, more security in the sense here. Just try to open SQL Server. This is SQL Server 2025. Okay, here it is asking me the server name, authentication modes. We have many authentication modes are we have, and we have to give username and password to enter into the SQL Server Studio. This is SSMS, SQL Server Management Studio. Okay, just wait, disconnecting. Okay, so it is asking me user ID and password, and it has many modes, login modes. Okay, it is providing more security, more security. Let me read that point. it is providing it is providing more security, okay, more security. That means it is, in the sense, RDBMS is providing more security. Okay, I have access to SQL server, but it is asking user ID and password. I have logged in, I have given the user ID and password, I have logged in. Okay, if I create any database in this, suppose I can create a database here, okay, like this. I can create a database here. Suppose if I create a database, any other user cannot access this database until I give permission, until I give user permission. In the same way, we have the same thing in Oracle also, and every RDBMS provides security. Okay, we need to give access privileges to the user to access the database. So RDBMS is providing more security. It is providing more security. Okay. Next one is guarantees data quality and consistency. Data quality and consistency. Try to understand this. Actually, RDBMS allows only valid data. Only valid data. That means correct data. Correct data. Okay. Just try to understand this example. Wait, where it is. Okay. Now see here. Just see this one. Employee. This is employee table. This is employee table. Okay, this is employee table. Now try to understand by seeing this table what we can understand here. See, employee ID is repeated. Duplicate ID. This means duplicate ID. And employee name is not there. That means missing name. And you see salary part, salary should be positive, but it is showing minus 2000. It should be positive, right? But it is negative value. Okay, salary must always be positive now. So okay, if we allow this, the database will contain wrong and inconsistent data. Okay, in case of RDBMS, we don't maintain like this. We don't maintain like this. Here, RDBMS provides rules and constraints to ensure only valid data. Okay, valid data is stored. Valid data is stored. Okay, quality means only correct data. Only correct or only correct or meaningful data, okay, is allowed. Okay, data consistency means the data is accurate and it is same across all the parts of the system. Okay, just see these examples. All the parts of the system. What I said here, data integrity, consistency, data quality and consistency, which guarantees data quality and consistency. Okay, now what we are saying is data consistency. The data is accurate and it is same across all the parts of the system. What does it mean? I have employee table. A is the name of the employee and his ID is employee number is 1. Okay, his department number is 10. I have one more table, project table. In the project table here, the name of the project table is project ID.dev team. Here I have, see these fields: employee number, employee name, department number, job title, working hours, start date, end date. Okay, if you see 1A10, employee number, employee name, 10 we have. Okay, 10 we have. Here the name of the employee is A, his employee ID is 1, and his department number is also 10. Whatever the data we have in employee table, the same data we have in this table also. Okay, that means data consistency. The data is accurate and it is same across all the parts of the system. What does it mean? The data is accurate and it is same across all the parts of the system. That is data consistency. So which guarantees, RDBMS guarantees data quality and consistency. Data quality and consistency. Okay, the next point is which supports data sharing. Which supports data sharing. Data sharing. Data sharing means it allows, RDBMS allows or supports data sharing. It allows multiple users and applications to access and use the same data at the same time. RDBMS supports data sharing. It allows multiple users and applications to access and use the same data at the same time. Okay, that means multiple users work at a time, and applications, you take web applications, you take mobile applications, we can connect at the same time to the same database and we can access the same data at the same time. That is it supports data sharing. Okay, and the next one is which supports transactions. What is a transaction? First, let us see what is a transaction. A transaction is a group of one or more SQL operations like insert, update, delete. Okay, that are treated as one single unit of work. Try to understand it. A transaction is a group of one or more SQL operations that are treated as one single unit of work. Okay, now don't think it is money transaction, just try to understand it. Here, which supports transactions means, here what it says is, actually we have ACID properties: atomicity, consistency, isolation, durability concepts. Okay, when it comes, we have a separate session for that in transactions. Now what it says is, all operations must succeed together, or none should happen. What it says, all operations must succeed together, because here it says is group of one or more SQL operations that are treated as single unit of work. Okay, and it is saying all operations must succeed together or none should happen. That means, imagine a bank transfer. Example, bank transfer. First one is, bank transfer involves two transactions. What is the first one? Deduct. Suppose account A, that means A's account, from A's account to B's account we are transferring the money. That means in the first case we have to deduct 1000 rupees we are going to transfer. That means deduct 1000 rupees from account A. And in the second case, add 1000 rupees to account B. Okay. Now this is a bank transfer. It is a transaction. What it is? Bank transfer. But this bank transfer, it's a transaction which has two things. So in the first case, it has to deduct 1000 rupees from A's account. Now. After that, it has to add that 1000 rupees to B's account. Okay. Now this deduct and add, these two operations, okay, will be considered as a single unit of work. It is just a transaction, one transaction. In that transaction, we have multiple operations and it is treated as a single unit of work. But the thing is, all operations must succeed together in a transaction. Otherwise, none should happen. If anything goes wrong in the second statement, it has to abort the first statement, the first query. Okay, if anything goes wrong, any statement, suppose here two statements are there, two queries are there. If anything goes wrong in any statement, it has to completely roll back the transaction. It has to cancel the transaction. Okay, so that is the meaning of what you call, it is a single unit of work and it has to work together. It has to be succeed and it also has to be succeed. If anything goes wrong with this, it has to cancel the entire transaction. If anything goes wrong with the first statement, it has to cancel the entire transaction. Okay, that means it supports transactions. Okay, even in movie tickets booking system, you try to observe that first, whenever you book a ticket, it checks the seat availability. It checks the seat availability and reserves that seat. That means it has to update the seat status now. After that, you make the payment. That means insert into, you have to pay the amount. Okay, that means it has to insert into payments table. And finally, it has to confirm the booking and it has to send a message to your mobile or WhatsApp, whatever it may be. Okay, SMS or WhatsApp. If anything goes wrong with any of the given what you call operations, if anything goes wrong there, it has to cancel the complete transaction. Okay, so that is about transaction concept. Okay, now let us see RDBMS softwares. These are, the first one is SQL Server. It's an RDBMS software which is developed by Microsoft, as I said earlier, Microsoft. And Oracle is from Oracle Corporation. And MySQL or MySQL both are same. Okay, it is from same Oracle Corporation. And DB2 is from IBM. It is from IBM. Okay, and also we have PostgreSQL. This is also RDBMS software. Okay, that means it is from PostgreSQL Global Development Group, and RDS, which is from Amazon. Okay, Amazon. Okay, and also we have NoSQL databases also, I told you, which contains unstructured data and semi-structured data. What are the examples? Examples for NoSQL databases. The first one is MongoDB and Cassandra are the examples for NoSQL databases. Okay. Now, till now we have seen RDBMS features. Okay. We have one more thing, Object Relational Database Management System, ORDBMS. Object Relational DBMS, database management system. What it is exactly? It is the combination of RDBMS plus OOPS concepts. OOPS, object-oriented programming. What is OOPS? Reusability and security, which provides security and which provides reusability. That means ORDBMS equal to RDBMS plus OOPS concepts. What we have? Reusability and security. Okay, security. But RDBMS is also providing for security now. So that's why in ORDBMS, actually it has taken reusability concept from OOPS. Okay, since RDBMS is already providing security, it has taken only reusability. Okay, and this RDBMS does not support reusability. Just this ORDBMS only supports reusability. Okay, so here SQL Server, Oracle, and PostgreSQL supports ORDBMS features, okay, but not completely. Okay, but not completely. This is ORDBMS. Okay, now let us stop here. Tomorrow we can see the remaining things. What are the features of SQL Server 2025 and client server architecture, components of SQL Server, many things are there. Okay, that we will see in the next class, in the next demo. Today is the first demo. Okay, we will meet tomorrow then. Any doubts?
Sir, I believe I'm the only one in this class.
Your voice is not clear, Syed.
Now I'm audible.
Okay, yeah, please tell me.
I think I am the only one in the Zoom call. No other person.
No, could you please type it in this chat box? We'll understand. Somehow it is not clear yet.
Now I'm audible.
Oh,
Hello.
Yeah.
I think I'm the only one person in this Zoom call.
You think?
I'm the only one person because I didn't see other people join this call.
Yes. We have add-on batch also. If anyone wants to join, they will also join.
Okay, I have two questions. So, do we have any topic to connect our SQL server with other ERPs like SAP, Microsoft Dynamics? Those are finance softwares.
No, we don't have that kind of topics to discuss. It is purely SQL Server. You will learn only development part. There is no, that means classes for connecting from other softwares to SQL Server kind of things.
Okay, and sir, how much hard disk we required, hard disk space required for this SQL server?
Hardly it takes 4 to 5 GB. That's it.
4 to 5 GB. And sir, how I will get these notes every day or somebody
Yes,
else?
you will daily notes you get it. After completion, of course, I will provide the remaining material. Okay, but I will share the daily notes. No issue. I will provide everything.
Okay, sir, I am just worried about the how our daily practicals is going on in SQL server.
Yes. Yes,
So,
practical sessions. That means the moment I start the concepts, I will explain the topics. I will explain the examples, each and everything. The same thing you will practice yourself.
okay, sir. So that practical thing, how I will be get, sir? by notes, written notes.
Yes, I will provide everything. I will tell you how to create the databases, how to create the tables, how to work with each and every. That means what you call, we have DMLs, data manipulation language kind of things. Okay, how to write each and every query efficiently. Those things I will explain. You will practice yourself. If you want, I will provide the database. Otherwise, you also can create database. I will tell you that how to do that.
Okay.
Okay, how to install SQL Server in your system. I will provide that document. If any problems you get, let me know. Then I will explain. I will see that later.
Okay, sir. That is the only one I have a doubt because I'm connecting with the tab and in the laptop it's both are different screen. That's why.
Okay, it is like, see, online also you can practice. In online also you can practice. Okay, there are many websites they are providing for practicing the queries. Okay, if you want, I will provide that link also. But the thing is, they are providing 2005 version or not, that I don't know. But 2022, I can tell you that it is there. You can create yourself a table, you can insert data, you can write your queries, everything you can do it. Or by default, they also provide one database and that you can practice your queries.
Okay.
If you don't have enough space to install SQL Server 2025.
So tomorrow I will share my screen from laptop. You can check.
Okay.
Okay, sir.
Yeah.
Yeah, that's it. That's it from my side, sir.
Okay, fine. Okay, tomorrow, same time, demo second demo we have. Okay. So we will see the architecture part and components of SQL Server. Many things are there. And installation also I will explain if I get time. Then I will explain that part also. Okay. Total 3 demos will be there. This is first demo, right? Okay, fine. We will meet tomorrow then.
Sure.
Okay, fine. Thank you. Bye.
Bye.